for the next video on basic circuit analysis, where we are going to solve problems related to transistor circuits. So specifically in this video, we will be concentrating on the common emitter configuration of bipolar junction transistor. So here is the circuit configuration for common emitter connection. So here, this is the input terminal, which is the base, where the input is applied between base and the emitter. This is your emitter terminal, and this is your collector terminal, and the output is taken from the collector and the emitter. So here, the emitter of the transistor is in common to both the input and the output circuits, and therefore the name comes as common emitter configuration. Now we will try to understand about the different parameters that are related to common emitter connection. So the first parameter that we are going to concentrate is base current amplification factor. So in common emitter connection, the input current is IB and the output current is IC, and we also know how to write the amplification factor, which is going to be the ratio of change in the output collector current to the change in the input base current, del IB, and this is denoted by beta. And we also know that if you're not going to consider any change in the current values, that too, if you're going to consider only the DC values of the current, then beta will be equal to IC by IB. And in almost any transistor, less than 5% of the emitter current flows as the base current. This is very common thing that we have discussed in the previous video also. Therefore, the value of beta is generally greater than 20. Now we need to understand the relationship between beta and alpha. Alpha is also the current amplification factor, which we have seen with respect to common base connection, and beta is the base current amplification factor for a common emitter configuration. So now we will understand a relationship between beta and alpha. As we know, beta is nothing but del IC by del IB. Alpha also we know that I've discussed in the previous video. The video link is shared in the description box below and in the I button, where alpha is del IC by del I. And we also know that the total emitter current would be the sum of base current and the collector current. This equation we can rewrite it as del IA equal to del IB plus del IC, or we can also write it as del IB equal to, I'll tell you why we are taking del IE and del IB, del IE minus del IC. So now we have to substitute the value of del IB in beta, because beta we know that it is del IC by del IB. Now you understand, right? Why do we take del IB from del IE expression? Now we have to substitute this here in the beta expression. Therefore, in the numerator, we will have it as del IC, and del IB will be del IE minus del IC. So now we need to divide the numerator and the denominator of this beta expression by del IE. So therefore, the expression will become del IC by del IE, and this will be del IE by del IE minus del IC by del I. And we know that what is del IC by del IE, which is alpha, and del IE by del IE becomes 1, and again del IC by del IE is alpha. Therefore, the relationship between beta and alpha is equal to beta is alpha by 1 minus alpha. And it is very clear from the expression of beta and alpha relationship that if alpha approaches unity, which means if alpha is going to be 1, then beta approaches infinity, because beta is equal to alpha by 0. Anything divided by 0 becomes infinity, and therefore beta becomes infinite. In other words, we can say that the current gain in a common emitter configuration is going to be very high. And it is due to this reason that this circuit arrangement is used in about 90 to 95% of all the transistor applications where high current gain is required. Now coming to the next parameter that we are interested in a common emitter configuration is the expression for the total collector current. And in common emitter circuit, we know that IB is the input current and IC is the output current. And we also know that IE is sum of IB plus IC. as per our previous discussions. And we also know one more formula where IC is equal to alpha times IE plus ICBO, which is from the common base configuration understanding, which I have explained in the previous video. So now coming to, let us have this expression as 1 and this one as 2. So from the expression 2, when we substitute it for IE, this will become alpha times IB plus IC plus ICBO. And we know the final expression of IC can also be written as alpha by 1 minus alpha into IB plus 1 by 1 minus alpha times ICBO. And we know that ICBO is the leakage current in the common base connection. Now from this last expression, it is very clear that if IB is going to be 0, so when IB becomes 0, when the base circuit is open. So when the base circuit is open, the base current will not be there and the collector current will be the current to the emitter. That collector to emitter current with base open is abbreviated as ICEO, and this is equivalent to 1 by 1 minus alpha into ICBO because the base circuit is open. So therefore, the collector current will be the current to the emitter. So now coming to substituting the values of 1 by 1 minus alpha ICBO as ICEO in this expression. So the expression for IC after all the substitution becomes alpha by 1 minus alpha into IB plus ICEO. And we also know that since beta is nothing but alpha by 1 minus alpha, we can rewrite the collector equation, current equation as beta times IB plus ICEO, which is the collector to emitter current with base open. Also, you can see here that beta plus 1 is nothing but 1 by 1 minus alpha. The proof I have given it here. So therefore, we can rewrite the collector to emitter current with base open as beta plus 1 times ICBO. Now we will solve one problem related to common emitter configuration. The problem statement says a transistor, that to here it is an NPN transistor which is connected in common emitter configuration, in which the collector supply is VCC, which is 5 volt, and the voltage drop across RC is 0.5 volt, where RC value is given as 500 ohms and alpha is given as 0.96, where we are asked to find out what is the collector to emitter voltage and the base current. Now to find out the first parameter, which is the collector to emitter voltage, this is your collector terminal and this is the emitter terminal. So across this you have a voltage which is collector to emitter voltage VCE, and here you have the collector terminal which is connected with VCC also, and there is a voltage drop which is ICRC. That voltage drop is already given as 0.5 volt. So therefore you can write it as VCC minus 0.5 volt. Instead, if it is not given, we will write it as IC into RC. We should find out IC and we have RC. You need to multiply and find out the voltage drop. But here in this problem, the voltage drop is given directly. So we just subtract it from the total supply voltage VCC. And we know VCC is 5 volts. So which is 5 minus 0.5, which is equal to 4.5 volt. Now the next objective is to find out the base current IB, for which we know the voltage drop across RC. So that we should understand first. And that is given as 0.5 volt. So this we can write. And IC, with that we can find out what is IC. IC is VC, the voltage drop across RC, divided by RC, which is 500 ohms. So this will give us a collector current of 1 milliamps. Therefore now the collector current is 1 milliamps. To find out IB, I need beta, because IB is nothing but IC by beta, where beta I can find out from the given alpha, where I know the relationship between beta and alpha is beta is equal to alpha by 1 minus alpha. This, if you're going to substitute alpha is equal to 0.96, this will give us a beta of 24. And now IB will be 1 milliamp divided by 24, which is equal to 41.6 microamps. Hope you all have understood about the common emitter configuration of an NPN transistor. We have started our discussion with common emitter configurations parameters, which are the current amplification factor beta, and we have also seen a relationship between alpha and beta, and finally we have derived the expression for the collector current in terms of ICBO, which is the collector to base leakage current with respect to emitter open in a common base configuration, and we have also seen IC with respect to ICEO, where we have discussed the concept of leakage current of common emitter to leakage current with base open. So all these relationships we have seen, and finally having all these equations at our hand, we have solved one problem related to common emitter configuration. We will continue to solve problems related to BJT circuits. Until then, stay safe. Thanks for watching this video through Electronics Insight channel.